Hey guys, I'm back with another video, and this video is going to be about GAN and CycleGAN, and although this might seem like gibberish at first, and alien words, don't worry, it will make sense and all your questions will get cleared up. Okay, so, but let's take a step back and start off with like a scene, okay? So you are an impressionist, you're a mimic, and you try, for a living, you try and impersonate other people, or maybe you do it for fun, I don't know, but you try and mimic other people, okay? And you have a performance tonight. Well, actually, you have a performance now. Okay, you're performing in front of an audience right now, and you're trying to mimic someone famous. Okay, you're trying to mimic a celebrity, and the only problem we have right now is that the audience can tell that you are not that celebrity. Okay, and so for your next performance, in order to, get better and actually not fail as miserably as you did last time, you bring in someone else. Okay, and actually, not for the next performance, but between your first performance and your second performance, you practice, right? But during your practice sessions, you call in someone else, and you call in maybe like a friend or someone, and they help you train, and like you try to impersonate that person, and then so that friend's helping you train, and you have a recording of the actual famous person talking, and then you say the same thing, and then your friend turns around and you either play the recording of the actual person speaking, or you speak yourself, and that your friend needs to discriminate and tell the difference, or be able to tell the difference between the actual person and you. Okay, and the more times your friend thinks that you are the actual person, you get better, right? And so it's like this back and forth. You have this, you speak, and then the recording speaks, and then you get so much better that your friend can't tell the difference anymore. Okay, let's just pretend that this is realistic, but okay, so now your friend can't tell the difference between you and the recording, and that means that you have gotten close to perfect. Okay, so this is the same thing that happens with GAN, and GAN is just like a generative adversarial network, and so for example, if you have like a data set of images, you're trying to generate a fake based on this set of images, just like you are trying to mimic and generate a quote-unquote fake voice based on the actual voice of the celebrity, okay? And so that's how it works. But on the side, you have another person who's telling you, hey, I can tell the difference. And then, because the difference might be very stark, right, at the beginning, but then as you get better, and as you get better from the feedback of your friend, the friend can't tell anymore towards the end, whether it's you speaking or the audio that you were playing. Okay, so same with the GAN, or GAN, whatever you want to call it. So you have a generator, and you have a discriminator. And so you have a generator and discriminator. And so you have a data set of real images, and your model is trying to generate a fake based on the image, the data that you have. And so you have two different networks going on, really, right? You have a generative network, something that's doing the generation, so the G in GAN. You have an adversarial, so you see the competition that's going on between the generator and the discriminator. It's not really a competition because at the end, like, the end goal is to improve the generator, right? So, but you can sort of visualize this competition between the two different networks, the generator and the discriminator. And so that's how it works. And they each try to outsmart each other. So let's start with a classic example, and like between zebras and horses, right? So you have a data set of zebras, of horses, and you try and generate a zebra based on the horse, okay? And so the first network generates the zebra based on the horses. Okay, so let's make this all clear. So you have horses and zebras. Okay, so the generator generates zebras based on the horse. The discriminator tells you whether that zebra is real or whether you came up with it, whether the model generated it. Okay, and if the discriminator can tell, then it sends a feedback back to the generator, and so the generator gets better, okay? And the main goal, like I said, is to produce an image or an example that cannot be recognized as real or fake. Okay, that's the main idea behind this. And this gave rise to CycleGAN, which is similar in nature, but it builded off of the GAN, okay, or GAN, okay. And so it can, what this does is that it can turn your horses into zebras without needing the data to be paired, right? So like this horse went to this zebra. Like it doesn't need to be paired. You can just have like a collection of horses and data and zebras in one data set, and your model can do the same sort of, cycle. But instead you have two GANs going on. So in the regular GAN, you have a generator and discriminator, right? So in two GANs, which is CycleGAN, you have two generators and two discriminators. And so when your horse turns into a zebra, zebra by the generator, and it's assessed and evaluated by the discriminator, the fake zebra turns back into a horse. So it's a fake horse from a fake zebra, okay? Okay, so you have horse to zebra, and then evaluation by the discriminator, and then zebra to horse. And the cycle, these two GANs kind of stabilize each other, so you don't have any major issues along the way. Okay, so that's what the idea is behind CycleGAN. So yeah, I think that's all I had for you guys today. Okay. So yeah. Okay, so we have GAN, and CycleGAN. Okay, cool. So you see this back and forth sort of thing that's going on. So yeah, so you can definitely use PyTorch to implement this if you wanted to. And I would definitely recommend reading more into this and seeing if this relates to whatever you're doing right now, or want to do. Okay, so yeah, thank you so much. I hope you learned something, and yeah, don't forget to stay curious. Thank you so much.